if you don't have a time
Probably should cut off,
constraint.
right? Library closes at 9, it's 8, 10.
Okay.
So,
I'll finish this in the next 5 to 10 minutes, hopefully.
For sure.
I'm not able to get there, but eventually we'll get there. Yeah, some of, okay, so did I miss anything critical? Yeah, we were sure.
Oh, the fees.
So, we, in a way, through these various questions, we touched upon how the ledger is being distributed, how the right version, if we get to the right version through the eventually consistent mechanism, why it is possible to hack the system as long as you own, you control 51% or more of the computers, right? And the moment, obviously, it's a pretty, we are normally talking about an open system, right? It's not supposed to be a closed system. There are private blockchains systems as well. But then we are talking about blockchain systems which are not meant for trust purposes between transacting parties. They are meant more for making sure that there is one authentic set of data that has to be used by different members of the blockchain. Right? So the way we were using it in my software company, it was a health insurance company that we are looking at. Provider data, that is doctor's data, right? Somewhere it is John Smith, somewhere it is John W. Smith, right? Or an H may be missing, right? So as the healthcare system works on the provider information, right? There are different stakeholders involved here. Providers themselves, the health insurance companies, the members, the payment processors, there are brokers, there are third-party administrators, there are different players in the system, right? They all need the right provider information, right? If we are talking about one source of truth, right, and that is what we talk about, if the provider himself or herself enters that information that my name is this, my address is this, these are my additional credentials, and he or she is the owner of that information, right? There everybody can then draw upon that information, right? And here, as of now, we all know, right? Data is a huge, the authenticity of the correctness of data is a huge problem in the industry out there. That itself is a big win, right? If we can get the right data, one single source of truth. So that can very well be say a Cigna, for example, can have a private blockchain system for this purpose, right? It is not worried about the trust part of it. It doesn't care about 51% ownership. All those things are not relevant, right? Because here it is all Cigna governed system for a different purpose. So it's a different variation of blockchain application, and it's a little bit of, it defeats the purpose, original purpose of blockchain, but it serves the purpose for which Cigna would be using it, right?
Hi, I have an example about healthcare. Sometime in October I went and I took the flu shot, and after that I had to visit my doctor, and immediately she says, oh, you took the flu shot on such and such a date. And I was surprised, how come I didn't tell you? And she says, any pharmacy you go to, they give you the flu shot, they have to give the information that the flu shot, whatever they got it from, that was used by this and this person. So she said, if you take it in the Walgreens pharmacy, means other pharmacy will have that information. So you are not given flu shot twice or thrice.
So that's a different application.
But that is again blockchain?
No,
or
that is not blockchain.
Okay, yeah.
It is just being as you took the flu shot, now this is my guess here, as soon as you took a flu shot, whosoever give the flu shot, whether it is CVS or a provider, whatever, right? They would probably have taken your health insurance information.
That's right.
All the treatment you go through, right, is captured by your health insurance provider.
Okay.
So nothing more happened here, just your flu shot information was given to the insurance provider. All right, and obviously that became the single source of information. You go anywhere else, the doctor or whatever, they get this information. So that is not blockchain per se. But I just wanted to give a different flavor of it.
Excuse me, I'm sorry, I need to leave early. I just want to get 3 definitions.
You talked about transaction, you talked about block, you talked about ledgers. Could you precisely define these terms and their relationship?
I think this is probably what you see is a very small ledger.
So which one is ledger in this picture?
No. So this series of blocks is the ledger.
Okay,
Or
that's definition one.
collection of blocks.
Okay.
Right, is the ledger. Right. Blocks can contain number of transactions that are being put together.
So not two, not one, so many.
Yeah, I don't know that precise number or how it works, but yes,
So
series
then
of.
what is the relationship of these transactions to this particular block? Why is it that I can't put all transactions in the same block?
Blocks are normally done in a time-bound fashion. I mean, this is historical. Probably this will change, but currently what is being done, let's say Bitcoin, it takes every 10 minutes they create a block.
Okay.
So in 10 minutes, whether there are 10,000 transactions, 10 million transactions, doesn't matter,
Okay.
it goes. So it's a time boxed.
Okay.
But there are Ethereum, there are some places they do 2 minutes.
So just they
One.
keep creating blocks,
Yes.
and whatever transactions are available, they drop it in that
Yeah.
block.
And it could be from anywhere,
Right.
any two parties.
Okay, thank you.
Okay. Are we?
I got it, thank you.
Then we quickly come to. So in a slightly ad hoc manner, but I think we largely covered the technological aspects of or the fundamental aspects of blockchain. I don't know if those who are practitioners, please let me know if I'm missing any critical piece or if I have not covered all the critical elements. If not, we jump to this, right? As he's talked about the fact that there are miners, right? The miners are putting in effort, they obviously want to earn some money back. Okay, how do they earn the money back, right? And we are, blockchain by definition, right, should not have a central authority. The moment payment is made in dollars, then there is a central authority that comes into play. Okay, and the Fed here can, I think, play around with it, right? It cannot cross borders, or if it can cross borders, the acceptance there may be challenges and so on and so forth. So, effectively, Satoshi, right, he created, I would say, Bitcoin as the currency for payment, because the currency had to meet the following criteria. It had to be in digital form, right? It had to be accepted in the real world, in all countries, no capital movement restrictions, trustworthy, and no single central organization or control. So, Bitcoin systems not only manages ownership of the digital money in the P2P system, but also compensates those peers with the money to whose integrity they contribute, right? So, in a way, it is like you work in a bakery and you get paid as like loaves of bread.
So, going through the effort from a computing standpoint, a power standpoint of validating a block, they're getting paid in Bitcoin.
Say that again, sorry?
In going through the process of validating a block,
Yes.
they're getting paid in Bitcoin.
If they validate, and the first one to validate, they get paid. If you fail, you don't get paid. Right?
Question.
And that is what happens here. The validation rules, and you get the reward if you are the first one, right, to crack. Punishment is nothing more than you put in the effort and you don't get anything for it. That's what it is, practically. There's competition, right? Only one person will get, one node will get paid, and so on. And the peer control part of it, right? There are others, as soon as you have validated, there are others who will assess and check that yes, what you have done is indeed right. If there is any malfunction from your end, whether it's intentional or otherwise, right, obviously they will say, and the money that was paid to you will be taken back, right, and it will be given to the other one. Please.
What is meant by crack? You just use the word cracking.
Validate, complete the validation.
Of the full
I don't know if I
ledger.
used it in any other form.
Validation of what exactly? Full ledger
Transaction.
or a block?
The transaction, the transaction has been done in the right manner. That means all the things that we talked right up front, the identity of
Yeah.
the owner and
But every single transaction, whosoever validates first gets paid.
That's correct. That's mining.
So at transaction level it happens, not at the block level.
No.
So whoever,
Oh, that part,
It is at a block level.
I am not so sure about that part,
Yeah,
right?
that's
I made me think, I don't know.
It's
No,
block,
it is
block
a
level
block
actually,
level.
it's a block level,
It's at the block level, okay?
not block, and they become the owner of that block kind of thing.
Okay.
So,
Following up on that, if it takes on average 250 kilowatt hours of power for what you wrote as a Bitcoin transaction, 250 kilowatt hours at 10 cents a kilowatt hour is $25. If someone buys a Starbucks coffee for $3, it can't cost $25. So presumably, the number of 250 kilowatt hours was for mining a new block, which contains perhaps hundreds, if not thousands,
Yeah.
or more transactions. So labeling that as a Bitcoin transaction makes it look like, how would this ever work?
Sure.
It's not a Bitcoin transaction, it's a particular type of transaction, creation of a new block.
That's right, you said it.
And so if you're collectively packing them in an efficient way, then that $25 to validate a block isn't so bad if you put 1,000 transactions in a block.
So it's not the amount only per se, right? It's the magnitude of the energy consumption and the wastage and all other things that go along with it, which is causing that heartburn out there.
What's the requirements by which?
Just one quick point. All those people who know and who are practitioners, if I'm missing a point, if I'm saying anything incorrectly, please don't have to wait for the session to get over and politely tell me that you said it wrong. No, I mean it with all sincerity. Right. Please raise your hand or just correct me. I will not take any offense at all. Right. In fact, I will learn that I made those mistakes. So please feel free, just in case if I don't know anything.
What's the requirements by which a new block would need to be created? Why couldn't a block contain an endless supply of transactions?
Sorry, I couldn't get a question.
What warrants a new block to be created with a new set of transactions? Why couldn't block 2 just continue to grow in transactions?
Time's up, trains leaving the station.
time box.
So one is the time part of it, right? So that blocks, so all the transactions that take place within, say, a 3-minute time window would be put together in one block.
Okay, it's
Alright.
time-based.
Something like that. Okay. It may be other systems might have different parameters, I don't know, but this is one that is certainly there for sure. Or there might be a minimum number or subject to this, I don't know what rules govern that.
How is the reward system ensured to be equitable? Like, does it depend on how large the box I have, my computational power? Is it dependent on?
Yeah.
If I have the biggest box, I'm always big enough, or?
It's a dog-eat-dog world. If you have a more powerful computer, right, and that, so you will be able to mine more. So because what you're doing is you're contributing more resources to the blockchain system.
So that's okay.
So, yeah, so you're welcome to bring in more powerful computers. Now, what is already also happening, going back to the point he was making, right, computers are becoming, the speed is going up, right, and energy consumption per unit is coming down, but the transactions obviously are growing exponentially. So the point here is the difficulty level of the puzzles are also being modulated accordingly.
Yeah,
Right,
every
just-
year, as the time goes, to solve the computation power to solve that puzzle, basically the number of leading zeros in a block that you need to come out to find out, that's what you need to spend hashing. You keep on adding it to the data, some salt, like some additional data to come out that leading zeros. That, and also the reward goes down and the complexity increases.
Okay, you keep talking about Bitcoin on it, and Bitcoin has this issue that, but look, let's do a practical application where you don't want to have this computational thing, what like inventory management system or supply chain or something like that. And you don't want this computational thing to be killing you, you just want it to manage transactions. Is that where, instead of Bitcoin, let's talk about other applications.
Yeah, so the one that probably is most, I would say, I don't know whether it is crossed Bitcoin network. Ethereum is the other one that I think is becoming more and more prevalent for variety of purposes. So likewise, there are multiple blockchains that are out there. If it has to do with integrity of transactions, I don't think there is any way out, right? But go through the entire system. Yeah, proof of work, if it is shifted to proof of stake, then yeah, the energy consumption will come down, the computational effort will come down. But I don't think, other than that, there is any way to short circuit the algorithm. The moment you do make any change, you are compromising the system out there. Transaction, you have to go through the whole 9 yards.
So in terms of the security, are you going to touch on that? It's using the existing security concept we have, or is it adding the new layer of?
Oh, you're talking about
Like you said,
so
public-
infrastructure and cybersecurity?
Yeah.
I don't know.
But that's the key basically. I want to identify myself on this open system. And there has to have a very secure
So,
way.
yeah, that I'm
No, it is using the existing security algorithms.
Yeah, it is a.
And so whatever is there. I mean, in security is not complete, you cannot
never
evade it.
absolute.
It is never 100%. So it is using the encryption algorithms which are currently available. You can use elliptical algorithms later or something else. So, but still it will be whatever security infrastructure that is available.
That's my belief too. And I think it has reached a fairly stable level, the existing security setup, right? We upload things on AWS, for example, and we don't bother, right? It has reached that level of comfort. Earlier, there were lots of issues, oh, can I put it on cloud and so on and so forth. Please.
If I grow oranges in Southern California, the unit of transaction might be a box of oranges.
Right.
The value of that on the scale of what we're talking about on the whole interaction is very small.
Sure.
So the amount of energy and time you want to put in on the security is probably very, very low, while the ability to trace it back to the grower, that box of oranges, because of legal liabilities, is very, very high. So you presumably would only take out one of those aspects and make that your primary concern, where all the rest of the stuff can fall by the wayside. They have a kind of a superficial level of.
So that is one of the reasons why some of the first applications were for high value goods,
Exactly.
right? The
Yeah.
jewelry and pharmaceutical drugs and so on, right?
Right.
What variations have been applied to grocery, right? Which is like, you can either apply to some sample as a representation that we were talking about, or there is some other mechanism by which a whole block of oranges is given one unit identification. I
And so
don't know.
like thought
Yeah.
of mentally, that you have all the stuff that went out today on a railroad car
Yeah.
full of stuff in one block.
Possible.
And it's a whole pile of serial numbers for stamps on,
Right.
not
Yeah.
every orange, but on every box.
What is that one unit?
Yeah,
Right, essentially.
definition.
Not one orange, not one box of 12 oranges, maybe one, I would say truck, I don't know.
Yeah, and the
I-
value is
Sure.
$9 or whatever.
The advantage is in when you have the grocery, when you mentioned, like spinach, if it has some problems where it was grown, and when it comes, if you can trace back within few seconds, you can announce it everywhere and you
Correct.
avoid the illegal problems to all the distributors,
That is true.
retailers and all that.
That's right. Very right. Please.
Could you flesh out or give an example of proof of stake as opposed to proof of work? I'm getting a little confused about those two concepts.
Here I can do with some help. I can take a shot in case if you know. Sorry?
Yeah, go ahead.
Okay. So proof of work, the
I kinda
puzzle
get
part.
that from
Right?
Bitcoin, yeah.
Proof of stake is what is the extent of ownership I have of the digital money which is associated with that blockchain system. So if I already own a significant amount of, say, bitcoins, right, there is a higher stake, and it is very similar to when we transact with people on eBay, right? We look at the feedback system, right, out there. So public would have given their feedback that yes, this seller, right, has a rating of 4.9 out of 5, right? In a way that a track record has been built, right? So we feel that yes, this seller has a higher stake in making sure that they continue to maintain the integrity or the trust of their business. you can draw a parallel to this. If I have significant stake in that system, right, by owning a fair percentage of money, and I think they have drawn some threshold, that means yes, and the different levels is what I remember. So the higher the stake, right, probably the less effort I have to put in, right, to do the validation. So it's my stake in making sure that the system thrives.
So somehow you're coming up with some measure that I have an incentive to keep the system working.
Correct.
And therefore I should be believed more, I should have more belief than the amount of effort I put in.
That's right. If Bitcoin networks integrity is compromised, Bitcoin value goes down and I lose. That's the essence. Please.